Guys, in previous class, we discussed about basic thing about the network, right? Everyone. In previous class, we discussed what is network, what is networking, what is the future of CCNA, and what are the things you need to do if you want to grow in the networking domain, right? As well as we discuss types of communication that is called unicast, multicast, and broadcast, right? Guys, after that, we discuss modes of communication. There are three modes of communication we discuss: simplex, half duplex, and full duplex. Am I right? Everyone, tell me. Okay. Now, moving to the next topic, guys. See, I already told you about the network. What do you mean by network? Network means when two or more devices are connected with each other and share the resources with each other, that is called network, right? Understand? Everyone, tell me yes or no. Right now, for example, if I have one device, if I have one device, can I create a network by the help of one device? Our answer is no. That is not possible. If we want to create a network, we need at least how many devices? We need at least two devices. Getting my point, everyone? So with the help of single device, we can't create a network. Clear? So now, for example, we have two devices and I connect both devices like this. Is this called a network? Answer is yes. That is called network. Why? Because here two devices are there, PC1 and PC2, and both devices are connected with each other, and both devices are sharing the resources with each other. Getting my point? So that's the reason it forms a network. Clear? But, but for example, my requirement is now different. Now my requirement is I need 3 to 4 PCs. I need 3 to 4 PCs in my network. For example, if we have a PC number 3, PC number 4, like this. So can I connect PC like this? Can I connect PC like this? Our answer is no. We cannot connect our PCs like this. So if we want to grow our network, if we want to expand our network, we can't connect the devices like this. What is the reason? The reason is, for example, if you are using the laptop, how many NIC card will be there, guys? There will be only two NIC card, right? One is for the Ethernet and one is for the wireless. Am I right, everyone? Yes or no? Right? Now we are not talking about the wireless, we are talking about the Ethernet. So only one NIC card is there for Ethernet connection. So if there is only one NIC card in your laptop, it means by the help of that NIC card, you can connect only one internet sources, or only one Ethernet cable, only one LAN cable. Yes or no? Everyone, tell me yes or no. Right now? So it means if we want to connect two devices with this PC, that is not possible. With this PC, you can connect maximum one device. You can't connect more than one device because at one PC, there will be only one NIC card. Is this clear to everyone? Let me know. Guys, is this clear? Okay. So now our requirement was we want to expand our network. So our requirement is we want 3 to 4 PCs or more than 3 to 4 PCs I want to connect in our network. So in this case, that is not possible to connect our devices one to one right now, because with one PC maximum one devices you can connect. Now what is the solution? Now in this case, guys, we need a networking device. What we need, guys? We need a networking device. Why? Because networking device gives us feasibility to connect number of devices in a network. Getting my point, everyone? Yes or no? Now, for example, that time we have a PC number 1, PC number 2, PC number 3, PC number 4, PC number 5, and PC number 6. For example, we have a total 6 PC, and I want to connect all the PCs and want to create a network. So all the PCs can share the resources with each other. All the PC can share the resources with each other. Can I connect like this? That is not possible, because again on this PC, how many LAN card you are connecting? How many Ethernet you are connecting? 1 and 2. That is not possible. On this PC, you can connect maximum 1. Getting my point? So that is not the solution. Getting my point? Everyone, yes or no? Clear na? So in this case, the solution is, if you want to create your network, and if you have a more than 2 or 3 or 4 devices, in this case, you need a networking device. So now we need to understand the networking device. First networking device that we are going to discuss, that is called switch. That is called switch. So what is switch, guys? Switch is a networking device. By the help of switch, we can connect multiple device in a network. Again, I am telling, what is switch, guys? What is switch, guys? Switch means, please remember here, by the help of this, we can connect multiple devices in a network. So all the devices can share the or can communicate with each other. That is the use of switch. So in this case, for example, if we take one switch, that is called, guys, that is switch. And by the help of this switch, what we can do, we can connect all the devices like this. All the devices like this. So see here, how many LAN card you are using right now on every PC? Only one. We are using only one LAN card is there, right? And now every PCs can communicate with each other. Every PC can communicate with each other. For example, if this PC wants to communicate with this PC, you can easily communicate. This PC will send the packet will reach on the switch, and switch will take the forwarding decision, and switch will forward your packet towards here. And when this PC will get forward the reply packet will come to the switch will forward the reply packet towards here. So by this way, you can easily communicate. Getting my point? So I hope now you guys understand what is the exact use of networking device, right? So by the help of networking device, what you can do? By the help of networking device, we can connect multiple devices in a network. Clear, guys? So what was the problem? Problem was, if we want to create multiple devices in our network, or if we want to expand our network, that was the problem. But once we have a networking device is solving our problem. By the help of networking device, we can expand our network easily. There is no problem. Getting my point? So there are, guys, multiple types of networking device. So the first device that we are going to discuss, that is called switch. I hope this is clear to all of you, everyone. Done, guys? Yes, exactly. So I'm writing guys couple of points about the switch. Okay. So I hope if you guys are writing, then please write. Otherwise, you guys can take the snap. Okay. Switch. What is the use of switch, guys? First point about the switch. This is a networking device that is used to connect multiple end devices, that is used to connect multiple end devices and make the communication possible. I hope you guys understand this point. Clear? Now, guys, in a networking, we need to follow some model. We need to follow some standard. And that standard is called, guys, OSI model. Now, what is OSI model? Why we need OSI model? What is the basic thing in the OSI model? We will discuss these things later. Okay. But right now, just understand. For example, if we want to create anything in a networking, for example, if I wants to create any devices, any protocols or anything in a networking, we need to follow some standard process. We need to follow some standard process, and that process is called, guys, OSI model. So OSI model is just like a reference model that provides you to do this one, to do this, do that, to do this, like this. Getting my point? So OSI model is just like a reference model. So if we wants to do anything, if we wants to develop anything in a networking, either you are developing any networking device, either you are developing any routing protocol or anything, you need to follow that reference model that is called OSI model. Now, inside the OSI model, guys, there are multiple layers. Inside the OSI model, there are multiple layers. Okay. What is that layer? We will discuss these things later. And what are the content inside all the layer? We will discuss these things later. Okay. But right now, I'm telling you, there are total 7 layer in the OSI model. Layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, and layer 7. Fine. Now, come to the switch. Switch is a layer 2 device according to the OSI model. Please remember this line. This is a layer 2 device according to OSI model. Please remember this line. Okay. So switch is a L2 device. Clear? Now, again, interviewer will ask you why switch is called L2 device. Why switch is called L2 device? Any idea why switch is called L2 device? There is a reason. There is a reason. Who can tell me the reason? Anyone who can tell me the reason, guys? Okay. If you guys remember, in yesterday class, I told you something about the logical address and physical address. Do you guys remember? I told you logical address and physical address, right? What do you mean by logical address? Logical address means the IP address that is called the logical address. And the physical address means the MAC address that is called the physical address. Right? Okay. Now, please remember one thing. MAC address works at layer number 2. MAC address is a layer 2 address. And IP address is called layer 3 address. I hope you guys remember these things. Done? Now, on the basis of this, we can define why switch is called L2 device. Guys, switch is called L2 device because switch will take every forwarding decision on the basis of layer 2 address that is called MAC address. For example, that is switch, that is PC, that is PC, that is PC. If this PC wants to communicate with this PC will send the packet reach onto the switch. What switch will do? Switch will open this packet and switch will check what is the source MAC and what is the destination MAC. And on the basis of this address, switch will take the forwarding decision. Getting my point? Either this switch will broadcast this packet or either switch will unicast this packet. Getting my point? But the thing is, what you need to understand, we need to understand switch is here taking the decision on the basis of which address, guys? Physical address. That is called MAC address. I hope this is clear to all of you. Done? Everyone? Clear? So that's the reason switch is called, guys, layer 2 device. Clear? So what is the answer? This is called L2 device because switch will take every decision on the basis of physical address called MAC address. I hope you guys understand. Clear? Now, come to the next point, guys. I told you in the yesterday class, switch is a intelligent device, right? Everyone, please remember, switch is an intelligent device. But again, the question is why? Why switch is called an intelligent device? Guys, we are intelligent. Why? Because we have a memory. We have a memory. And inside the memory, we can store the thing. And whatever the things you store in your mind, you can take any decision according to this. Yes or no? Everyone, tell me. Right? For example, if you are preparing for the exam, and you prepare for the exam and you go for the exam and after exam you realize you didn't pass, then definitely you guys will think na, this is the way I read the things, this is the way I prepare for the exam, but I didn't pass the exam. So I need to prepare something different. I need to do something different. Yes or no? That is the common behavior, right? In the same way, switch is also an intelligent device. It means switch definitely store something, and whatever the thing switch will store, switch will take the forwarding decision on the basis of this. Getting my point, everyone? So the answer is yes. It is an intelligent device. But why? Because it has memory. It has memory. Getting my point? And inside the memory, it maintain one table. And what is the name of that table, guys? Called MAC address table. MAC address table. Is this clear to all of you? Everyone, tell me. Right now, switch maintain one table and the name of that table is called MAC address table. Clear? And inside the MAC address table, definitely switch will store which information, guys? Switch will store the information about the MAC address. Now, maybe if any interviewer will try to ask you, tell me why switch is maintaining the MAC address table, why switch is not maintaining the IP address table. You can tell, sir, do you know one thing? Switch is a L2 device and switch is taking every decision on the basis of L2 address, that is called the MAC address. And I hope you know about the L2 address and L3 address. You can answer like this. Getting my point, everyone? Yes or no? Is this clear? Right? Switch is called L2 device. Why? Because switch is taking every decision on the basis of physical address that is called MAC address. Then why switch will prepare the IP address table? That is not possible. Getting my point, everyone? So that's the reason switch is maintaining the MAC address table. Is this clear? Everyone, tell me yes or no. Clear? Guys. Everyone, is this clear? Yes, exactly. Okay. So in MAC address table, do you know what exactly the things switch store? Anyone who can tell me? In MAC address table, what is the information switch is actually storing? See, I can show you. For example, right now we are using the packet tracer. I take one switch, and with this one switch, I take one PC here, one PC here. Let me connect both PCs. I connect both PCs like this. And I hope everyone already installed the packet tracer in your machine, because here we will do the practical. I come to this PC, go to the desktop, IP configuration. I am assigning the IP address, for example, 10.0.0.1. I assign the IP address. Fine. Link local address. That is the MAC address of this PC. Okay. I just copy this MAC address here and I write the MAC address. I just write the MAC address for our reference. Done. Come to this PC, desktop, IP 10.0.0.2. Here I copy the MAC address. Done. Is this clear, guys? Everyone, tell me yes or no. Is this clear? Now, on PC number one, I already assigned the IP address, guys, 10.0.0.1. Clear, guys? Yes or no? Done, na? Okay. Now, I come to the PC number one, go to the command prompt. I am writing ping 10.0.0.2. I am getting the reply. It means I am able to ping from this PC to this PC. How I am able to ping from this PC to this PC? In yesterday class, I already explained you. Right, everyone? How actually the PC number one will generate the ARP packet, how ICMP packet will generate, how ICMP packet first time ICMP packet will hold, how ARP packet will generate. In yesterday class, I already explained you. Right? Okay. So close it. Go to the switch. Go to the CLI. Enable. I will tell you guys in the detail way about the basic command. I am writing one command. I want to check the MAC address table on the switch, because I told you switch maintain one table that is called MAC address table. So what is the command to check the MAC address table, guys? The command is so MAC address table. This is the command. So MAC address table. I press enter. See, inside the MAC address table, this is the table which is maintaining. This is the table which maintaining. In this table, what are the content? In MAC address table, the first is, guys, VLAN. Second one is called MAC address. Third one is called type field. And the next one is called port number. Getting my point, everyone? Yes or no? Clear na? Now, what do you mean by this? What do you mean by this? See here. See very carefully, guys. Okay. See, first one is called VLAN. What is VLAN? Why we need VLAN? Leave it. We will discuss these things later in a very detailed way. Clear na? Right now, just understand on switch, whatever the ports is on the switch, every port is the part of VLAN number one. Okay. So by default, VLAN number one is configured on the switch. Clear? We can't edit VLAN number one. We can't delete VLAN number one. Nothing we can do. Clear? So by default, VLAN number one is there on the switch. Is this clear, guys? Everyone? Yes or no? Done? Guys, tell me right now. This is the new switch. I didn't do anything. So I'm just writing so VLAN. When I write so VLAN command, see, VLAN number 1 is already there. The name is default. I didn't create any VLAN. I didn't create any VLAN. I just take one switch and open the CLI. I didn't do anything. And when I write the command show VLAN, what I am getting? I am getting VLAN number 1 is already there. It means by default VLAN number 1 is there. And whatever the ports on the switch, every port is the part of which VLAN? VLAN number 1. Every port is the part of which VLAN, guys? VLAN number 1. Getting my point, everyone? Understand? So that's the reason I told you right now. Just understand, by default on the switch, VLAN number 1 is there and every port is the part of VLAN number 1. Clear? So that's the reason here VLAN and the number is 1. Now, MAC address table. In MAC address, guys, these are the MAC address. These two are the MAC address. See, 7EE7. 7EE7. This is the MAC address of PC number 1 and A295. 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 This is the MAC address of PC number 2. Clear, guys? Understand? So, guys, this is the MAC address of PC number 1 and this is the MAC address of PC number 2. Type is dynamic. Guys, there are two types. One is static, second one is dynamic. Dynamic means this switch learn this MAC address of PC1 and PC number 2 automatically. Right now, this switch learn the MAC address automatically. We didn't told this switch, hey, this is the MAC address of this PC and this is the MAC address of this PC. No, I didn't configure the MAC address manually on the switch. Getting my point? Switch learn the MAC address dynamically because this PC already exchanged the ARP. This PC already exchanged the ARP. And during the exchange of ARP, this switch already learned the MAC address of this PC and this PC. Right? So that's the reason type is dynamic. Clear? If you write the MAC address statically, then you will see there static. Clear now? But right now, switch learn the MAC address dynamically. So that's the reason type field is dynamic. Clear? Now there is a port. Now see, on this switch, how many ports are there? One port is called fast Ethernet 0x1 and second port is called, guys, fast Ethernet 0x2. When PC number 1 send the packet, in this packet, what will be the source MAC address, guys? 7EE7. That will be the source MAC address. So when this packet will reach on the switch open that packet and switch will check, oh, in this packet, what is the source MAC? Source MAC is 7EE7. And I am receiving this MAC address on which interface? Switch will understand, oh, I am receiving this MAC address on fast Ethernet 0x1. What switch will do? Switch will immediately maintain same entries in which table? MAC address table. Getting my point? So that's the reason switch maintain on fast Ethernet 0x1. I am receiving one MAC address that is called 7EE7 and switch maintain the same entry in the MAC address table. I hope this is clear to all of you, everyone. Done? Clear? So this packet reach onto the switch forward this packet towards the PC. This PC received the ARP request. Now this PC will generate the ARP reply. In this ARP reply, what will be the source MAC address? Source MAC address will be, guys, A295. Yes or no? Right? Source MAC address will be A295. And PC number 2 will send the ARP reply to this switch. Now, what switch will do? Switch will open that ARP reply and switch will find, oh, in this packet, source MAC address is A295. And I am receiving this MAC address on which interface? Fast Ethernet 0x2. Switch immediately maintain this entry in the MAC address table. And in MAC address table, switch maintain, oh, A295, this is the MAC address. And this MAC address I am receiving on which interface? Fast Ethernet 0x2. And both interface, fast Ethernet 0x1 and fast Ethernet 0x2, both interface is already part of by default which VLAN? VLAN number 1. Is this clear to all of you? Everyone, tell me yes or no. Done na? So that's the reason I am telling you switch is an intelligent device. So switch maintain which table, guys? MAC address table. Clear? And in the MAC address table, switch is installing the Switch is maintaining which entries? MAC address entries. On which interface I am receiving which MAC address. Clear? So now whenever switch will receive any packet, switch will check, oh, do I have this MAC address in my MAC address table? Switch will find, yes, I have this entry in my MAC address table. Now switch will take the forwarding decision on the basis of that table. For example, this PC and this PC already exchanged the ARP. Yes, guys, everyone, tell me yes or no, right? This PC and this PC already exchanged the ARP. Fine. And during the exchange of ARP, this PC maintain which table, guys? MAC address table, right? This is the MAC address table of this switch, right? This switch maintain the MAC address table, right? This switch maintain the MAC address table during the time of ARP exchange. ARP exchange. Clear? And guys, in yesterday class, I told you one more thing. If you guys remember, I told you this PC and this PC. This PC also maintain one table. What is the name of that table, guys? Anyone? The name of that table is, guys, ARP table. Right? Everyone, I told you. This PC also maintain one table that is called ARP table. Right? Go to this PC. Command prompt. How can you check? ARP space / A. See, when I write this command, this is the ARP table. And this ARP table, who maintain this ARP table? This PC maintain the ARP table. In ARP table, what is the entry? Who can tell me? In ARP table, switch maintain the entry IP address and what is the MAC address for that IP address. Again, I am telling. In the ARP table, switch maintain the entry of what? Switch maintain IP address and what is the MAC address for that IP. See, I run this command on this PC, right? On this PC, switch, this PC share the ARP request. This ARP request reach on the switch. Switch forward this ARP request to the PC. This PC will send the ARP reply. This ARP reply come to the switch. Switch forward this ARP reply to the PC. So this is the way how ARP exchange. I hope everyone know, right? When this ARP reply come to the PC, this PC open this ARP reply. In this ARP reply, what will be the content? Who can tell me? Source IP will be, guys, this PC IP address, that is 10.2. Now, what is the destination IP? Destination IP will be, guys, this PC IP address, that is 10.1. Now, in this ARP reply, what is the source MAC address? Source MAC address will be, guys, this PC MAC address, that is 8295. What is the destination MAC address? Destination MAC address will be this PC MAC address, that is, guys, 7EE7. I hope these things everyone know. Clear, guys? Everyone, tell me. Right? Now, this PC open this ARP reply. This is the ARP reply that PC number 1 received from PC number 2. Now, this PC open this ARP reply and check what is the source IP address and what is the source MAC address. Device always check the source MAC address for learning perspective. Getting my point? And for acknowledge perspective, they check the destination. Right? It doesn't mean so this device always check the destination. Sorry, source. No. First of all, this device check the destination IP address. Getting my point? If destination IP address will be same, that is configured on this PC, then after this PC will accept this packet. In the study class, I told you, right? If you guys remember, I connect multiple switches there. I connect multiple PCs there. And when ARP request reach onto the switch broadcast that packet, right? And every other PCs receive that packet, but all the other PCs drop that packet right now. Why? Because destination IP was different. In the same way, here when the ARP reply come to this PC will check what is the destination IP address. And the destination IP address will be, guys, 10.1. So this PC will accept this packet. Getting my point? After accept, this PC will check what is the source IP address and what is the what is the source IP address and what is the source MAC address. Now this PC will find source IP address is 10.2 and the source MAC address is A295. What is, guys? A295. Fine. So these are the two information this PC get. Now what this PC will do? This PC also maintain one table that is called ARP table. Switch if this PC immediately maintain these two entry in which table? ARP table. So see, that is the internet address, that is the IP address, that is the 10.2, right? And for this IP address, what is the MAC address? A295, right? That is the physical address, right? And PC learn this address dynamically. So type is dynamic. Is this clear to all of you? Everyone, tell me yes or no. Clear? Whatever the thing we discuss, I show you. Right? In the same way, come to this PC. This PC also maintain the same table. ARP space slash A. See, this PC also maintain source. When this PC receive the ARP request, this PC open that ARP request and check what is the source IP. In ARP request, source IP will be, guys, 10.1. So 10.1 is there. And what is the source MAC address? Source MAC address will be this PC MAC address, that is 7EE7. So see, that is the MAC address. Clear, guys? Understand? So by this way, switch maintain the MAC address table and PC maintain the ARP table. I hope everyone understand very clearly. Tell me, guys. Is this clear to all of you? Everyone? Okay, cool. So that is the fourth point, guys. Switch is an intelligent device, and I hope now everyone understand why switch is an intelligent device. Now come to the point number 5. Point number 5, the switch has many ports compared to router. Yes. If you compare with the router has less number of ports. Okay. But switch has, guys, number of ports, larger number of ports. Around, for example, if you are using the 9300 switches, that is currently we are using, and on this switch, generally we get how many ports, guys? 48 ports are there, right now. So that's the reason I am telling you switch has many ports compared to the router. It means on switch you can connect multiple end user device compared to the router. Is this clear? Everyone, tell me. Clear now? Everyone. Now, the most important thing, switch can unicast, multicast, and broadcast the packet. It means switch has ability to unicast, multicast, and broadcast a packet. Done, everyone. And I hope these things you guys know, right? Because in yesterday class also I told you how switch perform the unicast, how switch perform the broadcast. Getting my point, everyone? Yes or no? Right now, when switch received the ARP request, what switch was doing? Switch was broadcasting the packet, right? Everyone. When switch received the ARP request, switch was broadcasting the packet. And when switch received the ARP reply, in this case, switch was unicasting the packet. Getting my point? Yes or no? Is this clear? So we can say switch can unicast, multicast, and broadcast. Clear? Point number 7. That is very important point. All the interface of the switch will be in the same subnet or network. It means whatever the interface you have on the switch, all the interface must be in the same network. What do you mean by this? See here. For example, that is switch, PC, PC, PC. Is it possible? Here I configure the IP address 192.168.1.1, 192.168.2.1, 192.168.3.1, 192.168.4.1. Is this possible to configure the IP address like this? Everyone. Answer is no. This is not possible. Why? Guys, this is different subnet. This is different subnet. This is different and this is different. I am telling subnet. Subnet means network. So don't be confused. Okay. Subnet and network both are same. Clear? You guys will understand these things in more details when I will teach you the OSI model. Understand? Now, try to understand, guys, everyone. On this PC, we are using 192.168.1.1. That is the different network. And what I told you, all the interface of the switch will be in the same subnet. It means, on switch, we are not configuring the IP address. I hope everyone know, right? On switch interface, we are not configuring the IP address because switch port is called switch ports. All the interface of the switch is called switch port, right now? And switch port means that behave like a L2, right? L2 and L2 support MAC address only, not IP address. Getting my point? So that's the reason we are not configuring the IP address on the switch ports. Clear, guys? Understand? So on this PC, you assign 192.168.1.1. It means that is the part of 192.168.1.1. But again, you configure here 2.1, here 3.1, here 4.1. It means on every interface, you are configuring the different network ID. That is not possible by the help of switch, because switch is only responsible to make the communication possible in the same network. Please remember this line. Please remember this line. Switch is only responsible to make communication possible in same network. Getting my point, everyone? So that is the switch. Here is the PC. Here is the PC. Here is the PC. If you want to configure the IP address, you have to configure the IP address in the same network. For example, here I am configuring 10.1, 10.2, 10.3. That is fine. That is no problem. Whenever this PC wants to ping, this PC packet will reach here, switch will take the action because all the interface will be in the same network. In the same network. Getting my point? So if you want to make communication possible in the same network, you have to use switch. What you need to use, guys? You need to use switch. And by the help of switch, we can make communication possible. There is no problem. Done, everyone. I hope this is clear to all of you. Everyone. Guys, is this clear? Yes. And nowadays, guys, there are generally two types of switch you guys will see in the real-time network. One is called L2 switch and one is called L3 switch. One is called L2 switch and second one is called L3 switch. For example, on the packet tracer, when I take the switch 2960, that is the L2 switch. But again, if I take 3652, 3650, that is called L3 switch. That is called multi-layer switch. That is the L3 switch. Getting my point? Now, what do you mean by L2 switch and what do you mean by L3 switch? So please remember, L2 switch means, guys, that operates on L2 layer only. The switch that operates, I'm writing here, the switch that operates on Layer 2, it means it take forwarding decision on the basis of which address, guys? MAC address. That is called L2 switch. Understand, guys? For example, 2960, that model of switch is called L2 switch. Clear, guys? Now, what do you mean by L3 switch? What do you mean by L3 switch? The switch that operates at the L2 and L3, that is called L3 switch. That is called, guys, layer 3 switch. It means L3 switch has ability, yes, L3 switch has ability to perform the routing also. Because I told you, for example, if you want to make communication possible from one network to another network, for example, this is the PC number 1 and that is the PC number 2. Here I am using 10.1. Here I am using 10.2. Now, second scenario, same PC number 1, PC number 2. Here I am using IP address 10.1. Here I am using IP address 20.1. Guys, in case number 1, here both PCs are in the same network, right? So here we can use L2 switch. L2 switch. And this switch can make communication possible. There is no problem. But if this is the PC number 1 and this is the PC number 2, both PCs are in the different network. But here, if you use the L2 switch, this L2 switch will not help you to perform the communication here, guys, because both are in the different network. So in this case, what you need? You need L3 switch. That L3 switch will perform the routing as well. This switch has ability to perform the routing. This switch take the forwarding decision on the basis of L3 address, that is called IP address. I hope this is clear to all of you. Clear, guys, everyone. For example, nowadays we are using 9300 model switches. So that is called L3 switch. It means that switch can take the action, take the forwarding decision on the basis of IP address also. Getting my point, everyone? Yes or no? Done na? Clear, guys? Now, if anyone asks you, tell me what is the difference between L2 switch and L3 switch? Now you can easily tell L2 switch, L3 switch. L2 switch take the forwarding decision on the basis of MAC address, right? And it will take that forwarding decision on the basis of IP address. Clear na? L2 switch has no routing capability. No routing capability, right now? But L3 switch can perform the routing. Can perform the routing. So that is the second difference between L2 switch and L3 switch. Where we are using the L2 switch? In normal setup, in normal network setup, generally we are using the L2 switch. But if you have a larger network, where multiple VLANs are there we are using what? L3 switch. In larger network, we are using the L3 switch. For example, if in your company there are number of VLANs, so if you want to make communication possible between number of VLANs, what you need? You need to perform their inter-VLAN routing. What you need to do, guys? There you need to perform inter-VLAN routing. What do you mean by inter-VLAN routing? Inter-VLAN routing means the routing, or you can say the communication possible between different VLANs. Getting my point? So that is called inter-VLAN routing. Okay, so that is not possible by the help of L2 switch. L2 switch has no capability. L2 switch is not able to perform the inter-VLAN routing. So if you want to perform the inter-VLAN routing, what do you need? You need, guys, L3 switch. I hope this is clear to all of you. Done na? Clear, guys? L2 switch is generally cheaper, but this is expensive. This is expensive. Clear na? And if we talk about the speed, that is L2 switch is faster compared to the L3 switch. The reason is because guys on L3 switch, I'm not telling L3 switch is slow, but if we compare with the L2 switch, yes, there is slight slow. L2 switch is slight faster. The reason is because L3 switch needs to perform multiple things because L3 switch is performing the routing as well. Getting my point? So if L3 switch is performing the routing, switching, and everything, that definitely there will be some latency. So that's the reason. Clear now? So I hope now you guys understand what is the difference between L2 switch and L3 switch. Clear? Everyone, tell me. Is this clear, guys? Everyone? Cool. Okay. Now in switch, what is the problem, guys? We get on the switch. If we want to perform inter-VLAN routing, or if we want to make communication possible from one network to another network, which is not able to perform, right? So in this case, we need any device that is able to perform inter-VLAN routing as well as from one network to another network communication, right now. So that is called router. Clear now? What is, guys? Router. So what do you mean by router? Router, first of all, please remember, I told you, switch is called which layer device? Who can tell me? Switch is called which layer device, guys? Layer number 2, right now. So it works on layer number 3. Router works on which layer, guys? Please remember, router works on layer number 3. Clear na? And layer number 3 is known as network layer. Clear na? So router is called layer 3 device. Now again, if anyone asks you why, you can tell very easily, yes, router is called layer 3 device because router is taking every forwarding decision on the basis of logical address that is called IP address. Clear, guys? Everyone? Yes or no? Done? Now, on router, we can assign the IP address on its interface. On router interface, generally we are assigning the IP address. Clear, guys? Everyone? Yes or no? Right? Now, it connect multiple LAN. Yes, it connect multiple LAN. What do you mean by this? Try to understand. For example, that is my Noida branch office. That is my Gurugram branch office. That is Mumbai. That is Bangalore. Guys, tell me one thing. Inside the Noida branch office, whatever the network you are using, that is called LAN, WAN, CAN. Which type of network that is called? That is called LAN network, right? Inside the company, whatever the network you are using, inside the branch, whatever the network you are using, that is called local area network. That is called LAN network. I hope everyone knows these things. Done? Everyone, tell me, right? So here inside this branch, this is called LAN network, and LAN network. Yes or no? Everyone, tell me first. Right? Okay. Now, if you guys have some idea about the IP address, I hope you guys know there are basically two type of IP address. That is called private IP address and public IP address. Right? Private IP address is free of cost and public IP address is paid. It means if you want to use the public IP address, you have to purchase it from the ISP side. Right now, everyone. So there are basically two types of IP address, private and public. Done? Understand? Inside the LAN network, we are using the private IP address because company cannot afford the public IP address for each and every computer. Getting my point? So that's the reason we are using the private IP address inside our LAN network. Clear? But if you want to make communication possible with the internet, you must need public IP address. It means Google cannot understand your private IP address. That is not possible. Getting my point? Google always understand the public IP address. Clear na? What is the reason? What is the reason? Guys, tell me one thing. For example, right now I am using the laptop and in my laptop the IP address is 192.168.1.1 and that is the private IP address. And for example, that is the Google. You know what is the population of the world right now? Anyone? I I think there will be a in the billion, if I'm not wrong, right? 4, 5, 6 billions are there in the world right now, everyone. And you know, nowadays, a single people nowadays are using 2, 3, 4 devices. For example, I have two mobile phone, I have two laptops, one tablet. So whatever the device I am using, on every device there will be a IP address. Yes or no? Everyone tell me. Because every device is going to connect with the internet. So definitely without IP address, how can you connect with the internet? That is not possible. Right? So on my every device, there will be a IP address. I'm talking about me. It means I am handing total 4 or 5 devices. You can imagine the total population of the world is around 4, 5 billions. You can imagine how many IP address nowadays everyone is using. Getting my point? You can't imagine. And there will be a 110% chance if I am using 192.168.1.1, that private IP address, in a world, there are number of people who are using the same IP address at the same time. This is possible. Yes, that is common thing, brother. That is very common. Right now, same IP address in a world, number of people are using at this time. Right? Now, for example, this IP address now at the same time, for example, 1000 people are using at the same time this IP address in a world. And right now, for example, I open my browser and I am opening the facebook.com or any google.com, something. So it means my traffic will go on the Google server. Yes or no? Tell me guys, yes or no? Right? My traffic will go on the Google server. When this traffic will go on the Google server, what is the source IP address in this traffic or in the packet? Source IP address will be, guys, my IP address, that is 192.168.1.1. Am I right? Everyone, tell me yes or no. Right? Guys, no.
Yes, sir.
Marcelo is telling no. What, Marcelo? Okay. So, guys, this is the traffic. That traffic will reach because you will use a IP public for internet. No, I am telling you, if I am using the private IP address, then what will be the scenario? I'm not telling you about the public one. I'm telling you about the private one. We are talking the private one. Clear? Yes. So when, for example, when my device is sending the traffic and this traffic will reach onto the Google and with the source IP, guys, will be 192.168.1.1. Clear? Now, at the same time, what I told you, there are 1,000 number of people who are using the same IP address. Maybe 5, 6, 10 people are in the world who is searching or who is accessing same google.com at the same time when I am searching. That is common. That is possible. For example, that is Marcelo laptop is also using the same IP address 192.168.1.1 and he is also hitting the Google server. So now tell me one thing. Now Google will receive the same packet from Marcelo's side with the source IP address 192.168.1.1. Now tell me, Google will confuse yes or no? To whom I need to respond? Yes, that is the problem. Google will confuse to whom I need to respond because I am getting the two traffic with the source IP 192.168.1.1. One traffic is from the Shubham side and one traffic is from the Marcelo side. So where I need to forward that packet. That is the big problem with the Google. Right now, I am giving you the example of only two IP address. You can imagine in the world there are 4-5 billions. The population is the world. You can imagine how the complex our network will be. Right now, that will be the most challenging part. Clear na? So to avoid these things, we have a concept of public IP address. We have a concept of public IP address. And public IP address is always unique. Please remember, public IP address always be unique. Clear na? It means when Google server will receive any traffic, Google server always only and only accept the public IP address. Google server never understand the private one. Because if Google starts listening the private one, you can imagine how the traffic will be, how the network will be. Google will confuse and Google will dead. Right na? So that is not possible. Clear na? So that's the reason we have a concept of public IP address, and public IP address is, guys, paid, not free. Is this clear, guys? Everyone, I hope. Yes. Now guys, these are the LAN network. These are the LAN network. Clear na? And inside the LAN network, we are using the which IP address, guys? We are using the private IP address. Clear na? Now, for example, this is my company branches. These are my company branches. Then definitely we want not to communicate with each and every branches. Yes or no? Right? Definitely we want to communicate with each and every branches. Getting my point? Now, if I use here switch and I connect this LAN network like this, am I able to communicate? Answer is no. We cannot communicate like this. Why? The reason is this is the LAN network. For example, here I am using 192.168.1.0/24, this network. Here I am using 192.168.2.0/24. Here I am using 192.168.3.0/24. Here I am using 192.168.4.0/24. Getting my point, everyone? Yes or no? Tell me. Clear na? So in all the LAN network, we are using the different network ID. We are using different network ID. And here we are using the switch. That is the L2 device. And what I told you, switch is a L2 device. Switch is not able to perform routing. Switch is not able to forward your packet from one network to another network. If here this LAN wants to communicate with this LAN, packet will reach here, switch will drop it. Switch is not going to forward your packet from one network to another network. So what is the solution, guys? The solution is here we need to use the device that can perform the routing. That can perform the routing. That can forward our packet from one network to another network. That can connect multiple LAN network. That can connect multiple LAN network. That's the reason we are using which device, guys? A router. That's the reason we are using which device, guys? Router. Clear na? So I hope now you guys understand why we need router. Generally, router is used to make communication possible in into the different network, or you can say router is able to connect multiple LAN network. Clear, guys? Everyone? Yes or no? I hope this is clear to all of you, right? Yes, exactly. Now, one very interesting thing you need to understand about the router, that is, on router we can perform routing. I hope everyone know these things, right? Now, on router we can perform the routing. And in yesterday class I told you, if you want to perform the routing, what you need? You need a routing protocol. Yes or no, everyone? Right now, in yesterday class, I told you these things, right? It means on router, we can configure the routing protocol also, right? So on router, we can configure the routing protocols. Understand, guys? Everyone? Yes or no? Is this clear? Now, the most important thing you need to understand about the router. Router do not forward the broadcast packet from one network to another network. But yes, router can generate the broadcast packet within their local network. Please read this line very carefully. What I write? I write router do not forward the broadcast packet from one network to another. But yes, router can generate the broadcast packet within their local network. Do you have any idea? Everyone? Anyone? Do you have any idea? No? See, this is the router. This is the PC. This is the PC. Here I'm using the IP address 10.1. Here I'm using the IP address 10.10. Here I'm using the IP address 20.10. And here I'm using the IP address 20.1. Are you guys agree with it? Or anyone have any challenge with the IP address configuration? What the IP address I configure here? Anyone have any problem? Or I hope everyone understand how I configure the IP address. Everyone, tell me guys fast. Do you guys have any problem with the IP address that I configured here? No problem? Yes. Yes, Ahmed. What is the problem? I guess there is a problem. I am asking, what is the problem? First of all, tell me one thing. I told you, in this case, port router. Oh, tell me one thing. This is the router. How many interface, how many ports we are using on this router? One port is this one. Second port is this one. Agree? Everyone, tell me. These are the two ports we are using here. Why is not 192? It's up to me, na? You are telling 192.168.100.10. You are telling 192 this network. And I am telling I am using one. Here I am using 10.0.0.1. Here I am using 10.0.0.10. Here I am using 20.0.0.10. Here I am using 20.0.0.1. Now, any challenges? There is no challenges. Whatever the IP address I am using, there is no problem. But if you are using the router, make sure every interface is in the different network. Every interface is in the different network. So guys, this interface, what is the network I am using? We are using the 10th network. And here, what network we are using? We are using the 20 network. So there is no problem. This part is in 10th network and this part is in 20 network. Getting my point? That is fine. There is no problem. Clear, guys? Everyone, I hope. Are you understand, everyone? Tell me. Yes. Now, guys, for example, if I write here ping 20.1, anyone know what is how the packet will flow? If I write on PC number 1, if I write ping 20.1, do you guys know what happened? Okay, I'm just telling
I
you,
don't
please.
know.
First of all, when you write the command ping 20.1, PC perform which operation, guys? A and D operation. And according to the A and D operation, this PC will realize the IP address which you are pinging, that IP address belongs to the different network. Am I right, everyone? Not from this network. On this PC, which IP address you are using? 10.0.0.1 you are using. And this belongs to 10th network. Getting my point? But the IP which you are pinging, that is 20.1. It means that is from the different network, right? So now this PC realize the IP address which you are pinging, that is from the different network. So if the IP address will be in the different network, in this case, PC will forward the packet to the default gateway. Where, guys? Default gateway. Again, I am telling. Please remember, whenever you are pinging a network, whenever you are pinging an IP address, that if that IP address belongs to the different network, in this case, PC will always forward your packet to the default gateway. Understand like this. For example, I am working in my company, or for example, there is a team. In my team, for example, if I need any help from the HR side, and I know this HR is beyond me. For example, I cannot reach the HR directly. If I try to reach HR directly, I know she will not respond to me. What I will do? Definitely, I will reach out to my manager. Yes or no? Right? I will told him ki, hey, that is the problem I am facing. Could you please check with this HR? Now my manager will check with the HR. This is the process. Generally, we are following everyone. Yes or no? Right now. For example, if you are working in a team, you cannot reach any director or someone directly. Right now, we have a process. Getting my point? In the same way, for example, on the PC1, you are pinging 20.1, but PC number 1 perform the A and D operation. You can say A and D operation, or you can say PC1 think. But in the networking language, we are telling A and D operation. Understand? So PC perform the A and D operation, and PC realize that the IP address which you are pinging, that is beyond from this network. That is from the different network. So now this PC needs to reach its manager. And in the networking language, that is called default gateway. Now, what do you mean by default gateway, guys? Anyone? Please remember, default gateway. This is the exit point of a network. What is this? This is the exit point of a network. For example, if you are inside the room, if you are inside the room, if you want to exit in the room, and if someone wants to enter the room, this is possible by the help of door. Agree na everyone? Yes or no? Right? This is possible by the door only. It means if anyone wants to come enter my room, if anyone wants to exit my room, there is only one path, that is called door. Clear na everyone? Yes or no? I hope this is clear to all of you. Right? It means this is the door by which anyone can enter or by which anyone can exit. Clear na? So that is the door. In the same way, that is called which network, guys? 10th network. And this part is called which network, guys? 20 network. Right? For example, if there are multiple PCs are there, if there are multiple PCs, and if this PC wants to exit from 10th network, exit from 10th network, where is the door? This is the door. This is the door. Right now, if anyone wants, if any this PC wants to forward a packet from this network to another network, your packet will only exit by this port. Getting my point? And that is called default gateway. Clear na? So on default on this interface, what is the IP address you are using? You are using 10.0.0.10. So for this PC, the default gateway will be 10.0.0.10. I hope you guys understand what do you mean by default gateway. Is this clear to all of you? Everyone tell me. Right? Now, for this PC, what is the default gateway? Now I am asking to all of you. Who can tell me? For this PC, what will be the default gateway? Please write here, guys. Yes, exactly. 20.10. Exactly. Because for this PC belongs to which network? This network, 20 network. If this PC wants to share any packet from this network to another network, there is only one exit point, that is this exit point. And the IP address which you configured here, that is called 20.10. So that is the default gateway. I hope you guys understand very well. Clear, guys? Everyone, tell me yes or no. Understand? I hope now you guys understand about the default gateway. Right now, that is not too much difficult. Default gateway is very easy. Now, now, if this PC if you on PC number one, if you write ping 10.0.0.1, sorry, 20.0.0.1, this PC send your packet towards the default gateway. Where is the default gateway, guys? This is the default gateway, right? And this PC don't know what is the MAC address of 20.1. Agree? Everyone, tell me yes or no. This PC number one don't know what is the MAC address of 20.1. Agree na everyone? Yes or no? Yes, exactly. So what this PC number one will do? Who can tell me? PC number one will generate the which packet, guys? ARP packet. In yesterday class, I told you these things, right? ARP packet. Let me show you. See, come here. Okay. Packet flow in the same subnet. In yesterday class, I told you, right? I hope now you guys understand. If we are using the switch, how exactly the packet will flow between the PC1 to PC2, right? Everyone, tell me fast. Guys, right now, everyone, tell me, guys, yes or no? Yes. See, that is the PC number one. That is the PC number two. That is the switch. On PC number 1 IP address, we are using 10.1, MAC address is 0A. IP address, we are using the 10.2 and MAC address is 0B. Okay. Guys, for example, if you write here, everyone please see very carefully. Ping 10.0.0.2. What exactly happened? Here, when you write ping 10.0.0.2, please understand very carefully, guys. When you write 10.0.0.2, first of all, you need to understand ping. Ping, what is ping? Who can tell me? Anyone here who can tell me about the ping? What is ping? Who can tell me about the ping? Ping is the protocol, no? Test the communication. Yes, ping is used to test the communication, but the brother ping is not a protocol. Ping is for to show internet, no? Exactly. ICMP is the protocol, guys. Ping is a utility. Ping is just a utility that use the ICMP protocol. Please understand. Clear, guys? Everyone, yes or no? Is this clear to all of you? Tell me, guys, everyone, yes or no? Yes, ping is the utility. Getting my point? Ping is utility that use the ICMP protocol. Clear, guys? Okay. Now, when you write the ping command, guys, you know ping is the utility that use the ICMP protocol. So immediately one packet will generate. Guys, what happened, guys? One packet will generate. And inside the packet, how actually the packet will encapsulate? Please see very carefully. First of all, there will be a ICMP header. There will be a, guys, ICMP header. Clear? At which layer, guys? That will be at layer number 3. At layer number 3, which header will be, guys? ICMP header. Now, what ICMP will do? ICMP will hand over this header to layer number 3. At layer number 3, there is another protocol that is called IP protocol, IPv4 protocol. At which layer, guys? Layer number 3. Understand? At layer number 3, there will be a which protocol? IPv4 protocol. Clear na? So IPv4 protocol receive one, you can say payload from the ICMP protocol. Again, I'm telling, please see very carefully. See one thing. For example, if you ping na, what will happen? Immediately one packet will generate at that is called ICMP. In ICMP header, I will show you what are the content in the ICMP header. Now, what ICMP will do? ICMP hand over every information to layer number 3. At layer number 3, which protocol is there, guys? IPv4 protocol. Fine. What IPv4 protocol receive? IPv4 protocol receive this ICMP header from ICMP protocol. What layer 3 will do? Layer 3 will add here IPv4 header. Getting my point? IPv4 header. L3 will hand over to the L2. What L2 will do? L2 receive this payload from L3. L2 will add again Ethernet header here. And L2 will hand over to L1. L1 convert everything in the form of bits like this. So basically, this is the way how actually the packet will encapsulate here. This is the way how actually the packet will encapsulate here. Getting my point, everyone? Yes or no? Tell me first. Yes, this is the way how actually the packet will encapsulate. Clear na? Now, focus here one thing that we are discussing here. Okay, guys, packet flow I will tell you later. Right now, just focus one thing. What I told you, if we are using the router, I told you this PC don't know about the MAC address of this. So this PC generated the ARP. That is called ARP request. And that ARP request was the broadcast packet. I hope everyone remember. Right now, that ARP request was the broadcast packet. Right? Packet reach here, switch will broadcast it. Right? So for example, if there are another PC, all the other PC will receive that broadcast packet. Getting my point? But if you are using the router, for example, here is the PC1, here is the PC2, here is the PC3. Here you are using the 10.1, here you are using the 20.1, here you are using the 30.1. This PC generate the ARP packet reach on the router. Router never broadcast the packet. Router never forward the broadcast packet from one network to another network. Please remember these things. Clear? So that is the rule that I am trying to explain you. I hope this is clear to all of you. Everyone, tell me. Is this clear, guys? Everyone? Yes. There is a rule. Please remember, whenever router will receive any broadcast packet, router will never forward that packet to another network. Please remember these things. Yes. Yes, router never forward. Exactly. Router never forward your broadcast packet towards the different network. Is this clear to all of you? Everyone? Yes or no? Yes. Now, come here. This is the switch. This is the PC. This is the PC. Guys, what we are doing, we are discussing the packet flow between the same subnet. Okay. Here I am going to use the IP address 10.1. Here I am going to use the IP address 10.2. Everyone, please focus here. Come here on this PC, desktop IP configuration. I am assigning 10.0.0.1. This is the subnet mask by default. Here I do not need the default gateway. Why? Because we are pinging in the same network. If you need the communication in the same network, you do not need default gateway. Okay. This is the MAC address. I copy the MAC address. Let me write the MAC address here. This is the MAC address, guys, of this PC. Clear? Now come to this PC. Desktop configuration 10.0.0.2. This is the MAC address. Let me copy this MAC address. So guys, this is the MAC address of PC number 3. Done. I hope this is clear to all of you. Everyone. Clear? Now I will show you the packet. Go to the simulation. In simulation, there will be a edit filter. I do not want every packet. I want only ARP and ICMP. So let me remove it. I remove each and everything. Clear na? There will be other also. Let's leave it. No problem. Okay. Now I come to this PC number 2. Clear na? I go to the command prompt. I am writing ARP space A. Is there any entry in the ARP table right now, guys? Tell me. There is no entry in the ARP table. Everyone agree? Tell me, guys, everyone, yes or no? There is no entry, na? Okay. I am writing the command ping 10.0.0.2. If I am writing the command, guys, ping 10.0.0.2, what will happen? PC number 2 will perform the AND operation. Agree, everyone? Yes or no? Right? PC number 2 will perform the AND operation and PC number 2 will find, yes, the IP which you are pinging, that IP belongs to the same network, right? So in this case, this PC do not need default gateway. Clear? One thing. Second thing, when this PC will realize I do not need the default gateway, then PC will check the IP, which IP address you are pinging. You are pinging 10.0.0.2. Now this PC will check the ARP table. And in the ARP table, this PC is trying to find, do I have MAC address for this IP? Because if you remember, uh, 10 minutes before I show you ARP table entries. Right now, in ARP table, what are the information? IP address and what is the MAC address of that IP address. Right now, this is the entry in the ARP table. Yes or no? Right? So, this PC will check for 10.0.0.2. Do I have MAC address in my ARP table? But Sina, is there any entry in the ARP table right now? There is no entry in the ARP table right now, right? It means this PC number 2 don't know what is the MAC address of PC number 1. Getting my point? So if this PC don't know what is the MAC address of that PC, in this case, PC will generate which packet, guys? ARP. Getting my point, everyone? I hope you guys understand it. Clear? Understand? So I am writing 10.0.0.2, enter. See here. How many packets are there? Everyone. There are two packets there, ARP and C, ICMP. But first of all, this PC generate which packet, ARP or ICMP? Please remember, first of all, this PC generate the ICMP packet. First of all, which packet, guys? ICMP packet. Getting my point? Let me open the ICMP packet. This is the ICMP packet. Clear? Now see. Now see, this is the ICMP packet, guys. Now, what I told you, when you ping any device. Getting my point? So in this case, ping is the utility that use the ICMP protocol. So that's the reason here in this packet you are able to see what is this? That is called ICMP header. What is this, guys? That is called ICMP header. Clear na? So when you write the command ping 10.2, immediately which packet generate, guys? First of all, at layer number 3, there will be a ICMP header. In ICMP header, what are the content? First, type field. In type field, the value is 0x08. So please remember, there are two type of ICMP packet. In yesterday class, I told you. First one is called ICMP request and second one is called ICMP reply. Yes or no? So right now this PC number 2 is sending the request or reply? Request. So that's the reason type field is 0x08. Clear na? I will show you the reply also, don't worry. So please remember 0x08 means that is the ICMP request packet. Okay. Code. Code is something that is telling us more information about the ICMP. Okay. So in code field, always you will get the value 0x00. Checksum. Checksum is something, checksum is used to check is everything fine in the ICMP packet, yes or no. That is the use of checksum. Getting my point? Checksum is used to find the any error or anything in the ICMP packet. That's all. Clear na? Now that is the ID. That is something this is used for the integrity. And that is the sequence number. That is the first ICMP packet. This PC number one is generating. So that's the reason sequence number is 1. Clear, guys? So for example, sequence number is 01. So guys, that is the information in which packet, guys? ICMP packet. I hope this is clear to all of you. Is this clear? Everyone. Now, what ICMP will do, guys? ICMP will hand over this packet again to the layer number 3. Layer number 3. At layer number 3, we have a IP protocol. Which protocol, guys? IP protocol. So what ICMP protocol, what ICMP did? ICMP hand over this information to which one? IP protocol, and that is called payload. That is called, guys, payload. Getting my point? For example, if we have a, for example, my father, when my father will dead, my father will leave some wealth for me. Getting my point? Yes or no? Right now, that he earned. Getting my point? So that is called wealth for me. That is the wealth. Getting my point? In the same way, what ICMP is doing, ICMP generate this data, and now ICMP is handing over this data to the next generation, that is called L3. And for L3, that is called payload. In networking language, that is called payload. I hope this is clear to all of you, everyone, right? So ICMP receive this payload that is called, sorry, IP protocol receive this payload that is called ICMP request. Clear na? That is called, guys, payload from ICMP protocol. What ICMP protocol will do? For example, whatever the wealth I receive from my father, from next generation, what I will do? I will try to increase this wealth. Everyone is doing. Yes or no? Right na? In the same way, when this wealth is received by L3 or IP protocol, what IP protocol will do? IP protocol will add here something that is called IPv4 header. IP protocol will add here, guys, IPv4 header. Getting my point, everyone? Yes or no? Tell me first. Right? Now, come here. The thing right now, what you guys are seeing, that is called IP header. Here. That is called IP header. Getting my point? So there are multiple information in the IP header. Is this clear to all of you? Everyone, let me know first. Tell me, guys. Is this clear? Yes. Yes, that is called, guys, IP header. Okay. So in IP header, there are multiple content. Okay, na? But we need to focus on someone. We do not need to focus each and everything. That is version. Version means we are using IPv4. So that's the reason version is 4. That is the IHL. IHL means, guys, header length. Right now, that is the header length. That is telling the total size of the header is the 5 byte. Okay. Now, TL, total length. Total length means it is telling us the size of header as well as data, both. Getting my point? That is this one. Clear na? Now, flag. Flag is 0x0. Flag is 0x0. At IPv4, there are 3 types of flag. Okay, na? MF, DF, reserve. So that is something different. Leave it. Now, the next one is, guys, TTL value. TTL value is time to leave. Clear na? TTL value is telling us about the number of hops. How many hops are there? By default, if you are using the Windows PC, TTL value will be 128. But if you are using the Cisco iOS, for example, if you are using the router, then in this case, TTL value will be 255. Clear? Now, that is called protocol number. What is protocol number? Protocol number is telling us what is the payload we have. What is the payload IP protocol receive? So guys, tell me, IP protocol receive which payload? This payload. Yes or no? That is the payload, na? Everyone. That ICMP, L3 receive from ICMP, right? So what is the payload? The payload name is ICMP. And please remember, for ICMP, protocol number is 1. So that's the reason protocol number is 1 here. I hope this is clear, right now? So protocol number is 1 means 1 is telling us ICMP. Now we can easily understand. So the payload we have, that payload belongs to ICMP. That's all. Now this is the source IP address. That is a destination IP address. Clear now? Everyone. So that is the, guys, IP header. So what IP protocol will do? IP protocol will add here IP header. In IP header, first thing, source IP address. Source IP address will be 10.1. Destination IP address will be 10.2. Protocol number will be 01. TTL value will be 128. Clear na? That is called IP header. Clear? And the complete information at layer number 3, that is called packet. The complete information that you are able to see here, that is called packet. Clear? Now, what L3 will do, guys? L3 will hand over this packet. L3 will hand over this packet to which layer? Layer number 2. At which layer, guys? Layer number 2. So for layer number 2, that is payload. Getting my point? For layer number 2, that is called payload. Now, what layer number 2 will do? Who can tell me? What layer number 2 will do? Again, layer number 2 will add, guys, here Ethernet header. Which header, guys? Everyone. Layer number 2 will add, guys, Ethernet header. Clear na? In Ethernet header, what are the content you guys will get? First, source MAC. Now tell me, what is the source MAC address, guys? PC number 2 MAC address. That is the PC number 2 MAC address. Clear na? And one more thing. Please remember. At layer number 3, there is a which protocol? ICMP protocol that create this header. Yes or no? Done. ICMP hand over this to layer number 3. At layer number 3, there was which header, guys? Sorry, which protocol? There was IP protocol, right? That IP protocol is able to complete this packet. Yes or no? This IP protocol add the IPv4 header here. Yes or no? Right? Right now. And this IP protocol is responsible to encapsulate, or you can say to create this packet here. Now, this IP protocol hand over this packet or hand over this payload to layer number 2. Now, what layer number 2 will do? Layer number 2 receive this payload from IP protocol. Now, layer number 2 will add here which header, guys? Ethernet header. Now, definitely at layer number 2, there will be some protocol that will do this task. Yes or no? Please remember, in a networking, there will be a nothing that is happening automatically. If anything is happening automatically, please remember, definitely there will be any protocols or some algorithm. Getting my point? So guys, at layer number 2, we have a protocol that is called ARPA. Which protocol, guys? ARPA. Clear na? So ARPA protocol is, we can't hear you. I'm not audible, guys. Let me know, guys, fast. Okay, cool. So guys, at layer number 2, we have a protocol that is called ARPA. Okay. So what ARPA protocol will do? ARPA protocol will add here Ethernet header. In Ethernet header, what are the content? Source MAC, destination MAC, source MAC, destination MAC, then type field. Which field, guys? Type field. So these are the main 3 content Ethernet header. In Ethernet header, ARPA will add. Now, what is the source MAC address, guys? This PC MAC address, that is A93D. A93D. Clear? Type field. What type field is telling, guys? Type field is telling here. Come to the layer number 3 first. At layer number 3, what this field is telling? This field is telling you, na, what is the payload here, right? In the same way, at type field is telling you, the ARPA receive this payload. This payload belongs to which protocol? This payload belongs to which protocol? So there will be only 2 chances. One, either you receive the payload from IPv4 or either you receive the payload from ARP. If you receive the payload from IPv4, then value will be, guys, 0x0800. And if you receive the payload from ARP, then value will be 0x0806. Clear na? So in this case, ARPA receive this payload from which protocol? IP protocol, IPv4 protocol. So value will be, guys, 0x0800. Now, but the problem is, do we have destination MAC address? No, we do not have a destination MAC address. This ARPA protocol check which table, guys? ARP table. This ARPA protocol check the ARP table of this PC. And inside the ARP table, I already show you. Is there any entry? No, there was no entry. So it means there was no destination MAC address. Clear na? So in this case, you can say this packet is not completely encapsulated. Yes or no? Right na? You can say in this case, this packet is not completely encapsulated. At layer number 2, layer number 2 is not completely formed. So that's the reason in packet tracer, I hope you guys are able to see. Here IP header is there, but there is L2 header is missing. L2 header is missing. What is the reason? Because L2 in L2 header, everything is not there. In L2 header, destination MAC was missing. So that's the reason we are not able to see here L2 header. Getting my point, everyone? Yes or no? Understand? So that's the reason this packet is on hold. This packet is on hold. This ICMP packet will hold. Is this clear, guys? Everyone. Now, if anyone asks you why ICMP packet is hold here, how can you answer? You can say, yes, sir, this ICMP packet is hold because ARPA protocol do not, when ARPA protocol check the ARP table, in ARP table, ARPA protocol will not get the destination IP address, MAC address. That is called 10.2 10.2 this is the IP address, and for 10.2 there is no MAC entries in the ARP table, right? So ARPA is not able to encapsulate that packet completely. So that's the reason ICMP packet is now hold. Clear? Now, what ARPA will do, guys? Now, ARPA will hand over this task to ARP. What ARPA will do, guys? ARPA will hand over this task to ARP. ARPA will tell ARP, hey, I am not able to encapsulate the ICMP packet completely. Now I am giving you this task. Could you please help me one thing? Could you please find out the MAC address for 10.2? Now ARP will tell, yes, you are my brother. I will do these things. Getting my point? So that's the reason here after ICMP, you guys are able to see the different packet that is called ARP packet, because ARPA hand over this responsibility to ARP now. I hope these things you guys understand. Till now, anyone have any challenges, any problem? I hope you guys understand.